Welcome to another lecture of mine on discrete probability distributions. I've already uploaded a lecture on the general introduction to what probability distributions are. And we talked about discrete probability distributions and how to construct them. And the fact that they've made out of two columns, the random variable, which assigns numbers to outcomes of experiments, and the second column called probabilities, which assigns a probability to every outcome of the given experiment. In this lecture, I'll be talking about calculating the mean, which is known as the expected value, the variance, and the standard deviation of these probability distributions. And for that, I need to start by giving you the formulas first. The formula to calculate the expected value, which is the same thing as the mean of the experiment, also written as E of x, or just an E. The formula for that is the sum of the product of the values of your random variable and their corresponding probabilities over the entire distribution. So if I were to give you a quick example of how that will work out, if I look at the experiment of the gender sequencing experiment for 3 children, and I will write that up for you here. I'm sure you remember this from the previous lecture. So if I'm looking at number of girls, my possible outcomes in 3 births will be 0, 1, 2, and 3. And I've calculated the probability of each one of these for you guys on the last video. So we all are clear that this is 1/8, this is 3/8, this is 3/8, and this is 1/8. Now, what does the sum of xp means? Well, the sum of xp means I will take each x and I will multiply it to its corresponding probability. Then I'll take the second x and I'll multiply it to its corresponding probability. Then I take the third x and I multiply it to its corresponding probability. And then I take the fourth x and I multiply it to its corresponding probability. That's what this means, xp's. And then what that means that once you multiply all of these out, then you just sum them. So if I wanted to literally show you how this is done, of course, we'll do this on a spreadsheet, but I'll just show you manually how it's done without a spreadsheet so you could actually see it unfold. So to calculate the expected value for this experiment, I have to multiply 0 to 1/8. I have to multiply 1 to 3/8. I have to multiply 2 to 3/8. And I have to multiply 3 to 1/8. And then I have to add them up. And that's how you calculate the expected value of any given discrete probability distribution. You just multiply x's to p's, as many of them as you have, and then you add them all up. So this becomes, so the expected value becomes 0 plus 3/8 plus 6/8 plus 3/8. And if I add these together, that'll be 12/8. Now, recall that we're not necessarily obliged for writing fractions here, so I'll just, every time I get a fraction, I could just convert it to a decimal value, and 12/8, guys, is 1.5. So the expected value, the average number of girls in a family with 3 children is 1.5. Is basically, that's what it's trying to tell you. So that's how you calculate the expected value. So let me put it in the box. There we go. Now, I will show you how to calculate this on a spreadsheet once I'm gone through calculating all 3 items we need to calculate here, which is the mean, the variance, and the standard deviation. And I'll be doing it literally, I'm applying these formulas literally to this example. So we will have the final answers so we know what we're doing here. All right, so I'll start with the experiment of, with calculating the variance for this experiment of having 3 children. So the formula for the variance, so we have the formula for the expected value. Now the formula for the variance will be sigma squared, known as population variance. And that formula will be the sum, slightly more complicated than the expected value formula, but quite similar, x squared times p's minus mu squared. So we're summing up all the x square p's, and then from it, we're subtracting the square of the mean that you calculated in the previous step. So remember and mind you at this point that if I do not ask you for the expected value and I only ask you for the variance, you notice in order to do the variance, you have to calculate the expected value anyways, whether I ask you for not, because you kind of need to use it to calculate the variance anyhow. So one more time, whether I ask you for the expected value or not in this concept, you have to calculate the expected value if I'm asking you for the variance. All right, well, let's try to do this. So now what is this saying? Well, this is saying we're going to square the x's one by one and then multiply them to the corresponding p's. Then we will add them all up, and then from the result, we'll subtract the square of the mean we calculated in the previous step, which is 1.5 squared. Well, let's see how this will unfold. I'm going to write the probability distribution here one more time so I don't have to keep scrolling up and down here. So here's a probability distribution for number of girls in a family with 3 children in terms of their gender sequencing. So again, 0, 1, 2, and 3. Let me draw the separation columns here. All right. And my probabilities will be 1/8, 3/8, 3/8, and 1/8. Now let's calculate the the variance. So the variance will be x squared times p plus x squared times p plus x squared times p plus x squared times p minus the square of the mean. So we put all that in brackets because that calculation is done first, and then minus the mean squared, which is 1.5 squared. So basically, to calculate the variance, I need to do this out. Now, again, I'll do this for you manually here, but remember, asking you such questions, you will do this entirely on Excel, and you will just write the answer on your paper. So if I were to manually do this one more round, this will be 0, because 0 squared times anything is 0, plus 1 squared is 1 times 3/8 is 3/8, plus 2 squared is 4 times 3, 12/8. Plus 3 squared is 9. 9 times 1/8 is 9/8. And I will add these and I'll subtract from it 1.5 squared. Now if I add these three together, I'll get 24/8, which gives me basically 3 minus 1.5 squared. And if you do this on a calculator or on Excel, I shouldn't put an equal sign. No, I should put an almost equal sign because I'm approximating at this point. So the answer will be 0.8 if I'm only using one decimal place. And the number of decimal places you have to use will be indicated on a test, so you need not worry about that. So the variance of the experiment of having 3 children, when I'm interested in number of girls, is 0.8. Let me put that in a box. And now, once I calculate the variance, it will be quite simple for me to calculate the standard deviation, because the standard deviation is basically the square root of the variance. So if I write the square root of my variance, if I write the square root of my variance, which is the square root of 0.8, then I could very simply find the standard deviation. Now, if you do square root of 0.8 on your calculator and round it to 2 decimal places, this will turn out to be 0.89, which is pretty close to the variance in terms of numerically, but that's what it is. And if I round it to 1 decimal place, it'll just be 0.9. So there's my variance. Now, I'm going to try to show you how to do this on a spreadsheet. Now, I have a probability table set up here for me to type. So let's say I'm looking at the experiment of having 3 children. So I have my values are the values that the random variable assigns to the outcomes of the experiment is 0, 1, 2, and 3. My probabilities are 1/8. So you notice I don't just write 1/8. I write equal to 1/8. Equals to 3/8, equals to 3/8 and equals to 1/8. Now, these are my probabilities. Now, the sum of these probabilities always has to add up to 1. So if I add these probabilities, sum them, it should give me a 1, and it does. So I'm good with it, meaning I've constructed a proper probability distribution. Now I need to calculate three things. I need to calculate the mean, which is also the expected value. I need to calculate the variance, and I also want to calculate the standard deviation using a spreadsheet. So let's see if we could do this. So in order to do that, I need to create a couple of extra columns here. The first column I'm going to create, I'm going to call it the column of XP's. Why do I need to do that? Well, I need to multiply the X's to P's, as you noticed in the lecture, so I can calculate the mean of this distribution. And for that, all I have to do is take my X and I multiply it to my P. Now, all I have to do is fill it. So I'm going to drag it down. So if I drag it down, now it's constructed all the products of all my X's and P's. And if I want to add it now, and again, every time I add something, I like to change the color of the box in which I'm adding the number into. So if I sum these numbers, I get 1.5, and that's exactly what I had when I was doing it manually. So my expected value is 1.5, and you'll see that it also gives you 1.5 here. We calculated it with just a traditional style method when I was doing it on the actual lecture. Let's calculate the variance. Now, in order to calculate the variance, I need to create another column, and I need to call it x squared times p, because that's what I'm doing here. I'm squaring my x's. So I'm going to click on x. I'm going to square it. Then I'm going to multiply it to my probability. And now I've calculated the first one. I fill it or drag it down. And now I can add them. And again, every time I add something, I like to change the color. So let me add these together. So here the sum of my x squared p's, and I know that the variance is equal to the sum of x squared p's minus the square of the mean I calculated in the previous step. Again, the variance is the sum of x squared p's, which in this case is 3, minus the square of the expected value that I calculated to be 1.5. And that gives me 0.75. And if I round that to one decimal place, it'll just be 0.8. That's why when I was doing it on my lecture, I just wrote 0.8 because I was rounding into one decimal place. Again, that you don't need to worry about. You'll be instructed as to how many decimal places you should leave on the exam. And in order to calculate the standard deviation, I just need to do the square root of the variance, and there's my standard deviation. And again, I can round that to any value. So if I wanted to round these to one decimal place, let's say my variance would have been 0.8 and my standard deviation would have been 0.9. And that would have been the answer to this exercise in terms of calculating the mean, the variance, and the standard deviation using a spreadsheet. Let's try to calculate another one. Let's go back to our lecture. Let's try to calculate the variance, standard deviation, and expected value of this experiment now. So let's talk about the experiment of making a $100 bet on a game of roulette. So let's look at this example now. Let me change my marker here. So I have an example here. We're trying to find the expected value, the variance, and the standard deviation for a $100 bet on a number. Because there are many different ways of betting in this game, but we're only focusing on betting on a number in a game of roulette. Now, we constructed the probability distribution for the game of roulette for a $100 bet on a number previously, so I'll just write it out for you guys. So I write my random variable, and I write my outcomes. My outcomes are I lose, which means I've lost my initial $100 bet, or I win, which means and recall the payoff is 36 times. So I win 3,600, but $100 of it was mine. So the net winning will be $3,500. The probability that you will win is, well, you're betting on 1 out of 38 numbers. So the probability that you win $3,500 is 1 out of 38. And you're not betting on the other 37 numbers. So obviously, if any of those hits, you're going to lose. So the probability of losing will be the rest of them, which is 37 out of 38. And these are my probabilities. So, and if I wanted to write this as a decimal, it would have been 0.9737. And this would have been 0.0263. So if I wanted to calculate the expected value here, again, I'll multiply each x by its corresponding probability, and I add them up. So my second x is 3,500 multiplied by its corresponding probability, and since I only have two outcomes, then I'll only have two numbers that I'll have to sum together. And if I sum these together, and I'll leave these calculations up to you, I'll get negative 5.3 rounded to 1 decimal place. All right, so I've calculated the expected value. Let's try to calculate the variance. The variance for this probability distribution, again, will be the sum of x squared p's minus mu squared. Let's actually do this manually again. So you get minus 100 squared multiplied by its corresponding probability plus 3,500 squared multiplied by its corresponding probability. And then I have to subtract from that negative 5.3 quantity squared. And if I do the math for that properly, I'll end up with 332,105.3 minus 5.3 squared. And if I do the math for that right, I get 332077, 332077.21. So therefore, yeah, usually variance for these examples are pretty large. Don't panic and don't mistrust the number you've calculated. You're correct. So this is 332,077.21, and that will be my variance. Now, at this point, I could very easily calculate my standard deviation, since my standard deviation is basically the square root of the variance. So my standard deviation will be the square root of that value. Let me calculate that, the square root of, and I'm doing this on a spreadsheet next to me that's open. I'm going to do the square root of 332077.21. And if I do the square root of that value, I get 576.261. And again, I can round this to any value. Since I've rounded my variance to 2 decimal places, let me leave this to 2 decimal places as well. So my standard deviation at this point would simply be 576.26. And that's how you calculate the standard deviation. Very well. I'm going to do one more example, and then I'll leave it to you guys to do the rest of the practices. You have to do a whole bunch of these to be comfortable calculating these three quantities: the mean, the variance, and the standard deviation. So let's look at another example, and that'll do it for us. And let's look at the lottery ticket example, which is quite interesting. Let's recall that lottery ticket. And the best way to have you recall it is for me to give you the probability distribution table and how it looked. So we had our random variable assigned values to the outcomes, and those values were the winnings. And then we were also given the corresponding probabilities for these values. So we were told that you would win $1,000 with a 1 in a 3,000 chance. And remember, you paid $20 to buy the ticket. So if you're winning 1,000, your net winnings is $980. So to win 1,000, or basically 980, you do that with a probability of 1 out of 3,000. So I'll write that. Then you win 500, so I'll write 480, because I take out the $20 investment I made to buy the ticket. And the probability of winning 500 or 480 is 1 out of 1,000, so it'll be 1 out of 1,000. All right. Next, it says you would win $300, so you would win 280 actually. And if you win $300, it says the probability that you do that is 1 out of 500, so that's 1 out of 500. The next thing it says is you will win $20, but since you're buying the ticket for $20 for that particular item, your net winnings will be 0. Yes, you still have to write it. And the corresponding probability for that will be 1 out of 200. And it doesn't tell me anything else about the winnings, but remember, when you're buying a lottery ticket or you're gambling, it's not just winning, but it's also possible for you to lose, with a high possibility that is. So you're forgetting one other outcome, and that is the loss outcome. So these are all the winning outcomes. You're not just going to win in this game, you may also what? Lose. And that has to correspond to some kind of a value, and we're going to label that as -20, because if you lose the $20 you paid to buy the ticket, then you just lost that $20 if you don't win anything. And how am I going to calculate the probability of losing $20 since they haven't given it to me in the exercise? Well, I have to recall something I asked you to recall a while ago, is that the sum of the probabilities in a probability distribution always add to 1. Now, remembering that, I know that all my probabilities here, all of these probabilities have to add to 1. Well, this makes sense, because if they all have to add to 1 and I need to find that missing probability, then I could do that by adding up all the previous probabilities and subtracting it from 1. I'll write the traditional style of writing it here, and then I'll show you how it's done on a spreadsheet. So you basically add all the existing probabilities, and I assure you, you don't have to worry about finding a common denominator. You could do this entirely on a spreadsheet. So you add these probabilities, and you subtract it from 1. And that gives you that missing probability. And I'm going to go ahead and write that missing probability here. That missing probability will simply be, and I've calculated it, it's on your PowerPoint, using 4 decimal places for that, or 5 decimal places for that. I'll be 0.99167. So we 0.99167. I'm not going to write the fraction version of it because we're not expected here to find common denominators with such ugly fractions. Okie dokie. So now we're ready to calculate the variance, the expected value, and the standard deviation. Again, I'll do this traditionally for you guys. The expected value here will be the product of all my XPs. So it'll be 980 multiplied by 1 over 3,000 plus 480 multiplied by 1 over 1,000 plus 280 multiplied by 1 over 500 plus 0, obviously, and plus -20 multiplied by 0.99167. And if I do that on a spreadsheet or on a calculator, I can clearly see that I'll get an answer of -18.5. So that will tell me that my expected value, which is the average of this experiment, is -18.5. And that becomes my expected value. I am going to talk just a couple of minutes on the meaning of what this is, that this value you get -18.5. All that means is that if you're a lottery company and you're selling tickets to your clients, to customers, to the general public for this lottery, and they each spending $20 buying this ticket, in the long run, out of every $20 ticket you sell, you're going to make $18.50 profit in the long run, on the average. So basically, you lose about $1.50 out of every 20, but your average winning is about $18.50 per bet. So, or if you look at it from a customer point of view, every customer that plays this game is expected, and they're playing it for a long time, every customer is expected to lose $18.50 out of every $20 bet he or she makes. So that's the meaning of a probability, the average of a probability distribution. It has a sort of a long-term definition. It always tells you what happens in the long run. So if you buy this ticket once, none of these numbers apply to you. If you play this game 5 times, none of these numbers apply to you. These numbers only become significant if you play this game for millions and millions and millions of times. All right, moving on. Now we need to calculate the variance. The variance for this problem will be the sum, again, of x squared p's minus mu squared. Now, I have calculated the sum of x squared p's. You could verify that with me on a spreadsheet. Be 1104 minus 18.47. Here I'm using 2 decimal places instead of 5 squared, and that'll give me 762.9. And that becomes my variance. So my variance then becomes 762.9, and I'm going to put that in a box. And if I calculate the square root of this value, which is 762.9, on a spreadsheet, I'll get 27.6. So my standard deviation is 27.6. So that's how you calculate, once more, the expected value, the variance, and the standard deviation of a probability distribution. Now let's go to our spreadsheet, and let's try to do that on Excel. I'm going to call the first X. I'm going to call the second one P. My winnings lined up is 980, 480, 280. It was $20 winning, but net zero, and a negative 20 for loss if I lose the bet or the ticket. Now the probability here is 1 out of 3,000. So what we want to do is just type these probabilities. So the first one is 1 out of 3,000. So 1 out of 3,000. Of course, you get a 0 because you need to make the column a little wider so you could see the numbers. And here, I'm going to write the expected value here. This time, I'm going to write it as E of x. And I'm going to, this be variance, sigma squared, and the standard deviation. So this is what I like to calculate. I'm going to leave some space for these to be calculated. Excellent. All right, so my second probability for 480 or winning $500 is 1 out of 1,000. So it's 1 out of 1,000. The calculation, the probability for winning $300 is 1 out of 500. So it's 1 out of 500. The probability of winning $20, which for us will be a net of 0, is 1 out of 200. So it's 1 out of 200. And the last probability, as I said, is equal to 1 minus the sum of the rest of these probabilities. So that's the command to calculate the last probability. And again, in order for me to make sure I've done this properly, I need to add these up to make sure they all add up to 1. And they do, thank God. So I've written all my probabilities correctly. So now it's time for us to calculate the expected value. Well, in order to calculate the expected value, I have to figure out my XP's. Well, equals X times P. I drag it down, and I simply add them up. And that will be my expected value. So my expected value is basically this number there. So here I just say equal to, click on that number, and I can just transfer that number there. There's my expected value. Now how am I going to calculate my variance? Okay, let's calculate x squared p's again, equals x to the power of 2 times x squared times p. X squared times p. Now I do that to all the rest of them in this table, drag it down, and I add them together, because I need to add them to calculate the variance. All right, so I'm going to label this with some other color. I'm running out of colors. Let's label it blue. All right, so now what would be my variance? My variance would be that final number that you've added minus the square of the expected value you calculated in the previous step. So that will be my variance, 762.98. which is 763 actually. And the standard deviation would be the square root of my variance. which will be 27.62. Now, if you have rounded numbers off and you're going to calculate these based on rounded numbers, then you may get slightly different answers. Don't panic. Just remember, try not to round anything while you're doing your calculations or while your calculations are going on. Because if you round stuff during your calculations, then you're going to get slightly different answers that I'm getting, and that may freak you out. So try not to round anything and round everything at the end. All right, so here's how you calculated the expected value variance and the standard deviation. I've shown you how to calculate the expected values and variances and standard deviations for 3 different experiments. We did it for the experiment of the gender sequencing for 3 children, where we were interested in number of girls, calculated all 3. Then we looked at the experiment of the game of roulette and making a $100 bet. And we ultimately looked at the lottery example I'd given on my PowerPoint. Fantastic. Now it's time for you guys to practice this a whole lot more to be comfortable with it. You should try to do this manually like I did it here, let's say. First, get comfortable with the concept and then transfer it to Excel. Try to do it easier. All right, guys, I'll see you next time, and we'll be talking about binomial probability distribution. Have a nice one.